This math problem went viral all over the world. Seems to be quite tricky and also quite deceiving to our mind too. Let's consider. I have rupees 50. For the general case of a mathematician's idea, changing the currency notation doesn't imply in getting the perfect answer accurately. And considering that if you spend rupees 50 out of rupees 30, which makes the balance as rupees 14 is a foolish aspect that humans do. Let's move on to the concept and the question here. Let's consider I have rupees 50 where in the first trial I spent rupees 20 which makes the balance as rupees 30. In the second trial I spent rupees 15 which makes the balance as rupees 15. In the third trial I spent rupees 9 which makes the balance as 6. And at final trial I spent the whole 6 rupees at a time which leads to the balance to be as 0. Well, so far so good. But when we observe here, the summation of the literals in the spent part, which is 50, which is the actual value what we had at the initial. But when we move and check in the balance column, the summation of the literal is not rupees 50. It's 51 actually on summation. From where does this 1 rupee come from? Okay. I thank Sophia and Ellen for suggesting me this problem on social media. And for the initial, from where does this 1 rupee come from? Is there any calculus mistake or both the columns have any mistake by default? No. The mistake is not from any case of the observation, but well, the question itself is a misleading part. Well, I too got confused at my first sight. Later, I realized that on changing the values spent adversely affect the balance column, like rupees 52, rupees 64, 76 and more. To illustrate these 52, 64 and more, I use some of the examples in this solving process which clears the confusion by that. Let's take some example where the initial amount to be considered as 15 in all three examples. Let's move on. Let me spend rupees 20 at first trial which makes the balance as rupees 30, and in the second trial I spend rupees 8 which makes the balance as 22. In the third trial, I spend the whole amount 22 at a time which makes the balance as 0. Again, when we consider the summation of the literals on the either side, the spent column leads to the initial value which is rupees 50, but the balance column which is actually 52 on the summation which is not equal to rupees 50. Well, let's consider two examples more and discuss this aspect as a brief. Let's consider the second example where I spent rupees 22 at my first trial which makes balance as rupees 28. In the second trial I spent rupees 10 which makes the balance as rupees 18. And at the third and fourth and fifth trial I spent rupees 6 particularly which makes the balance as rupees 12, 6 and 0. On considering the summation of the literals on the either side, we get the spent part to be equal to rupees 50 which was the initial amount what we considered, but when we check the balance part, we could see that the summation of the literals there leads to rupees 64. Okay, whether this balance part always be greater than 50? No, that's a wrong statement. We have another example where the balance part is less than 50 for the same instance. Let's consider the third example here where I spend rupees 40 on my first trial which makes the balance as rupees 10, and at my second trial I spend rupees 10 as a whole which makes the balance as 0. On considering the summation on either sides, we get rupees 50 which was the initial in the spent column which was the initial part in the spent column When we consider the summation in the balance column, we get rupees 10, which is much more less than rupees 50. Where did this 40 rupees escape to? Well, on getting an analogy on these examples and many more trial and error method, we could conclude by a proportionality statement by this problem. The statement leads to constant related to rupees 25 is directly proportional to 1 by summation in balance column, or it can be stated in another way, that is constant related to rupees 25 is inversely proportional to summation in balance column. Explained as, if we consider at the first real the number greater than 25, which is half of 50, the number greater than 25, then the balance column, the summation of the balance column would be less than 50. And in many example it goes like this. And when we consider the amount less than 25 in the first real, which makes the balance column to be more than rupees 50. While after considering these examples, I can conclude that the spend column need not to be equal to the balance column. Even if hereafter people continue to believe that spend column must be equal to the balance column, then I mean today to have a consensus as follows. If you spend rupees 25 on your balance would be rupees 25 out of 50. I mean, if you spend rupees 25 out of 50, your balance would be rupees 25. But this doesn't mean that if you spend rupees 30 out of rupees 50, then your balance also need to be rupees 30. That doesn't mean at any case. If you spend rupees 30 out of 50, then your balance obviously be rupees 20 but not rupees 30. We all know the balance part need not to be equal to the spent graph. But this question totally depends on the way how our mind keep getting confused, and that's what the question setter used to confuse audience frequently. And especially in this question, the number of people who get confused will increase geometrically because the difference between the summation of amount spent and the summation of the amount remained in the balance column is only rupees 1. Incredible. The bottom line of the solution is that the summation of the literals in the balance column need not be equal to the summation of the literals in the spent column. Well, this is in the special case that the question setter tries to mislead the audience by just 1 rupee. Thanks for making this video a proud part, and thank you.